Okay, this is a grade 11 measurement problem from Fishhook High School 2015. And, well, let's just try it. It says you have been hired to help design a bus shelter. Okay, a bus shelter. The shelter is made from two cylindrical pillars and a hemispherical shell, as shown below. I took a real picture of a piece of metal, a lamp actually, but you can see there's a hemisphere, and this hemisphere is sitting on two cylinders like this that go right up to the top. They're right to the bottom of the hemisphere. My wife was telling me it's not so easy to see what the heck's going on with this picture for some people. They don't see it. We don't all see things the same way. So that's what's going on. It looks like that. Now, they tell a story here. They say the top shell, this piece of metal, it's hollow. This piece of metal here is hollow, but it's 5 centimeters thick. Between here, between the two cylinders that are on the inside, it's 3 meters. The cylinders are 2 meters high, but the radius of these cylinders is 10 centimeters, which is 1/10 of a meter. You know, you have to put everything in the right units or things just don't work. Let's try the first question. It says, how much metal would you require to make the top shell? And this is a hemisphere. Now, you're given all these formulas. Now, maybe you remember from grade 9. This is the formula for the area of a cylinder. 2 circles on top, 2 pi r squareds, and 2 pi r times h. The circumference, 2 pi r times h. That's the surface area of a cylinder. The volume of a cylinder is pi r squared, the circle on the top, times how tall it is, h. Okay. Now, this other volume here is the volume of a sphere, 4/3 pi r cubed. But we've got a half a sphere, so we're probably going to need half of it. This is the area of the hemisphere, okay? That's the area of a whole sphere. We're going to have to think about, let's just do we're just thinking about the hemisphere, so we're thinking about volume. So the only formula here, the right formula, must be 4/3 pi r cubed. Let's take a look. Now, you might want to stop the video and think, that isn't the right formula. You need to do something with it. You could stop the video and see if you can write down the right formula. And if you wrote down the right formula, I guess you've stopped the video, then you wrote down the right formula, it'd be there. It's half of it, 2/3 pi r cubed. There's the formula we need. Well, to use this formula, we're going to need the radius. Well, how much is the radius of this whole sphere on the outside, the big one on the outside? Well, it must be, if the radius of these cylinders is 10 centimeters, look at this picture. It's 3 meters plus 0.2 meters and 0.2 meters, 20 centimeters. It's 3 meters plus 40 centimeters. This whole distance across here must be 3.4 meters. So what's the radius? We're going to look at the outer sphere now. We've got to get the radius of this outer sphere. That's the outer sphere, the outer hemisphere. And if you've done it right, you'll get the radius. It's 3.4 all the way across. It's half of the diameter. It must be 1.7 meters. Well, there's the outside one. But they say that this hemisphere here is, if we go back here, it's 5 centimeters thick. So this inner sphere must be just 5 centimeters on this side, 5 centimeters on this side, just 10 centimeters, 1/10 of a meter less. So see if you can work out the radius of the inner sphere. You could stop the video and try it. You could do it this way, you know. What's the radius of the inner sphere? Because you're going to need it. And let's see here. Well, it turns out that it's just 5 centimeters on both sides. Instead of 3.4, it's 3.3. Now, we've got the right formula. This is the volume of the hemisphere. But there's a big one on the outside. And then there's a small one, the volume of the smaller hemisphere on the inside, the one that's 5 centimeters less. Well, how could we figure out the volume that we need to do the metal? How could we find the volume of the shell? How could we use this formula? We need the one on the outer one and the inner one. We use the formula. Guess what we do? Well, you could stop the video and think about what you do. What you should do is find the volume of the big one and subtract the volume of the small one. Now look at this. I can put this 2/3 pi r cubed. There's the big one, 2/3 pi r cubed. There's the smaller one. If I subtract, I'll get the amount of metal that you need to take. Here, I did a little trick on the calculator. I saw that 2/3 pi was in both, and I remembered I could factor it out and just go 1.7 cubed minus 1.65 cubed times it by 2/3 pi, hit that decimal button, and I get 0.88 cubic meters. And there's the answer to the first question. There's 2 more questions in here. Take a little bit long to do them all, so let's just stop it there.